Welcome everybody to the June Stockton Astronomical Society meeting. That's a mouthful. Just a reminder, if you get here after 6:30, the doors closed. You have to go around to the front of the building and come in. So we don't have to worry about people knocking on the door and we're going and opening it now. The sign is up. After 6:30, they should come through the front door. And all that much better that we're locked in and safe, right?
It says 640 sign.
It says 640?
It does say 640.
Oh, boy, yeah. They'll learn the hard way. We'll change the sign, Pat.
But we're all here. So.
Yeah. Okay. Well, welcome everybody on Zoom. Michael, Ray, Jerry, I see you guys there. Our speakers, Richard and Ruth, are with us. We'll introduce them in just a moment. Our normal format for this evening, we'll have our presentation followed by Q&A. Then we've got our series of general announcements and then some kind of interactive discussion we're going to have on a couple of topics. So looking forward to that part. So without ado, let me introduce our speakers for the night. Ruth, I'm sorry, I didn't ask you how to pronounce your last name. That's a little tricky one.
Kurisu.
Kurisu, okay. Mm-hmm. Thank you. So let's start off with Ruth first then. Ruth Kurisu's career path has been diverse, from quality control chemist to nuclear quality engineer and manager to entrepreneur. She combined her strong technical background with managerial talents to incorporate her own high-tech company in the electronics industry. Very impressive. Additionally, Ruth founded several nonprofit organizations to improve healthcare to those in need. Now retired, she has become an award-winning pastel artist and photographer exhibiting in galleries throughout Southern California. Oh, I'd like to see some of your work sometime. Ruth hails from New Jersey, received her Bachelor of Science in Chemistry from Ursinus College in Collegeville, Pennsylvania, and her MBA from UCLA, Anderson School of Management. So welcome, Ruth.
Thank you. It's a pleasure being here tonight.
Richard's probably a familiar face to you all. Richard presented to the club in March, I think it was. Richard Stember is a scientist, inventor, software entrepreneur, and published author. Richard founded and leads the nonprofit organization Science Heads Incorporated, whose mission is to promote science literacy and STEM education. Richard has a Bachelor's of Science degree in chemistry from the State University of New York, and he is well known in the field of chemistry, informatics, and laboratory data management. So let's give Ruth and Richard a welcome to the meeting tonight and look forward to the presentation.
Thank you. It's a pleasure to be here, and Richard and I are excited to share information with you about commercializing space and the future of space exploration. But as Albert Einstein once said, if you want to know the future, look at the past. So I'd like to kick this off by giving you a very brief Reader's Digest, very condensed version of the history of NASA. Next slide. This actually all started back in 1915. Woodrow Wilson was concerned that the Americans were falling behind the Europeans in the development and manufacture of aircraft. So he formed the National Advisory Committee for Aeronautics. It was founded with $5,000 and 12 unpaid members. Over the next 40 years, it conducted a tremendous amount of aeronautical research that was ultimately transferred into the nascent aerospace industry. Now, in the 1950s, pilots were taking experimental planes like the X-15 higher and faster than ever before. And the NACA actually thought about putting a human into space. They developed a plan that called for a blunt-bodied spacecraft that would re-enter the atmosphere with a heat shield, and also a worldwide tracking network, which is our deep space network today. Next slide. Well, the space age actually began in 1955. At that time, scientists all around the world were really dedicated to understanding our planet better. And they thought the best way to do that would be to observe it from above. So they formed the International Geophysical Year, which was to run from July 1st of 1957 to December 31st of 1958. And both the Americans and the Soviets pledged to put a scientific satellite into orbit around Earth to study our planet and its environment. Now, as you might imagine, both countries approached this in a very different manner. The Soviets operated in total secrecy. We had no idea what they were working on, and it wasn't until October 4th of 1957 they announced that they had launched Sputnik. But Sputnik did not contain any scientific instrumentation. But nonetheless, that 184-pound ball really made a large impact in our space program. And of course, a further impact was when the Russians put Lieutenant Yuri Gagarin as the first human into orbit around Earth in 1961. Next slide. Now, the Eisenhower administration, for their project of the International Geophysical Year, was the Vanguard project. Unlike the Soviets, however, we did this in front of the world press. The rocket went about 4 feet off the pad. One of the thrusters failed, and it came back to Earth in a huge fireball. Now, the tiny instrument that you can see the engineers holding did contain scientific instrumentation. It was thrown clear and only slightly a little worse for the wearer, but scientists were able to reclaim it and to save the scientific instrumentation. But this public humiliation forced President Eisenhower to address the Army, the Navy, and the Air Force, and basically said, you will have a scientific satellite into orbit around Earth within 90 days. Absolutely no pressure there, right? Next slide. So the Army came up and designed Explorer 1. It was our first science robot. It was built by Caltech's Jet Propulsion Laboratory here in Pasadena. And you can see it was rather small. It could be held overhead triumphantly. And I say triumphantly because the first time we ventured into space, we discovered something that nobody even knew existed. Next slide. We discovered the Van Allen radiation belts. Now, these belts are made up of electrons and charged particles that move about the speed of light, about 186,000 miles per hour. They're shaped like giant donuts with the Earth at the center. Now, they can be hazardous to our spacecraft, but they do protect our planet and all of us on it from harmful particles and energy from the sun, the solar wind. They received the last transmission from Explorer 1 in May of 1958. But that little tiny satellite was very determined. It didn't burn up in our atmosphere until March of 1970, after making over 58,000 orbits. It orbited about 1,500 miles above the surface. And from 1958 on, another 100 or so spacecraft would fall under that Explorer designation. Next slide. At the time, Lyndon Johnson was the chairman of the Special Committee on Space and Astronautics. And he said there are no blueprints or roadmaps which clearly mark out the course. The limits of the job are no less than the limits of the universe. Next slide. In April of 1958, President Eisenhower asked Congress to pass legislation to create a civilian space agency to oversee all of our nation's space activities. Congress passed the National Aeronautics and Space Administration Act. And in July, President Eisenhower commissioned Dr. Keith Glennon as its administrator and Dr. Hugh Dryden as the deputy administrator. And on October 1st of 1958, NASA was born. The NACA was dissolved and all of its assets and personnel were transferred over to this new organization. Next slide. The first project was Project Mercury. It was initiated in 1958, and the objective was to place a manned spacecraft in orbital flight around the Earth, to investigate the performance capabilities of that person and his ability to function in space, and of course, to recover that man and the spacecraft and bring it back to Earth safely. The first flight project was successfully accomplished, and it took over 2 million people from many different government agencies, much of the aerospace industries, universities, research areas, combining their skills, their initiatives, and their experience into a national effort. In addition to the 6 manned missions, there were 20 unmanned Project Mercury missions. Next slide. This is the Mercury 7, the brave 7 men who volunteered to go into the unknown. Alan Shepard became the first American to fly into space in 1961. And on February 20th of 1962, John Glenn was the first American to orbit the Earth. Next slide, please. On that day, he also became the first astronaut to ever take a photograph from space. This photo was taken with a camera that was purchased from a drugstore and was modified for one-hand use. And this is one of the images that he took during the first 3 orbits. Next slide. That was followed by Project Gemini. This was our bridge to get a man on the moon. The first crewed flight of Project Gemini orbited the Earth 3 times. And over the next 9 flights, scientists and astronauts developed and tested the technology and skills that would be needed for a successful moon landing. During this project, NASA also invented the fuel cell, which used the chemical reaction of liquid oxygen and liquid hydrogen to generate electricity. And this provided enough power and enough water for astronauts to break the human spaceflight endurance record. The Gemini missions also established the technology for astronauts to meet and dock with other spacecraft while in flight, and of course honed their skills at re-entering Earth's atmosphere and landing safely. Next slide. Just 60 years, a few days ago, was the first American walk in space. Ed White was the first astronaut to leave the spacecraft. He spent 23 minutes outside, and he logged over 6,500 frequent flyer miles. Next slide. That led us to the Apollo program. President Kennedy set the goal of landing a man on the moon and returning him safely to Earth within the decade. And that promise and pledge was made in 1961. I don't know if any of you are old enough to remember July 20th of 1969. I know I was glued to a little black and white television set, waiting and waiting and waiting, and just holding my breath until Neil Armstrong said that's one small step for a man and one giant leap for mankind. But the project Apollo's goals actually went beyond landing someone on the moon and returning them safely to Earth. The goals were to establish the technology to meet other national interests in space and to achieve preeminence in space for the United States. Also to carry out a scientific exploration of the moon and develop the human capability to work in that lunar environment. There were 6 lunar landings made during the Apollo program. Next slide. And during that time, it was the first time we ever drove on the moon, July 31st of 1971. Jim Irwin took the lunar rover out for a little spin. And I remember it very well. I was telling Tim before we started, my dad worked for RCA in Camden, New Jersey, and his division worked on the communications for the Mercury, the Gemini, and the Apollo missions. July 31st was my wedding day. And my father refused to walk me down the aisle. And I have to say, I refused to go until we knew that the rover was deployed and was roving on the moon. It did not bode well for my marriage, but that's another story. Next slide, please. As I was researching this, I totally forgot about Skylab and how important that was. That was really the highlight, I think, of the 70s. This was our first space station. This was done to prove that humans could live and work in space for extended periods, and also to expand our knowledge of solar astronomy well beyond what we could see here from Earth. Next slide. Now, the Skylab crew was tasked with a rather important mission to save Skylab. Skylab ran into serious trouble immediately after launch on May 14th of 1973. The station's micrometeoroid shell deployed prematurely. It deployed 63 seconds into the flight, and the aerodynamic forces just tore it off the vehicle. It also, in doing that, removed Skylab's thermal protection in the process. Additionally, the workshop's 2 main solar arrays failed to deploy. So the 2 events left Skylab in a very dangerous and perilous condition. It was overheated and short of power. So the mission of the first crew was to save Skylab. The crew's motto was, "We can fix anything." So the engineers sat down with a group of seamstresses, sewed together a huge parasol, which was then launched through an air hatch to cover up the workshop area. And it worked. 3 3-man crews occupied Skylab for a total of 171 days and 13 hours. They traveled round trip aboard the Apollo spacecraft. And it was the site of over 300 scientific and technical experiments, including medical experiments on humans' adaptability to zero gravity, and the solar observations and detailed observations of Earth's resources. Next slide. This, of course, led to the space shuttle. Now we knew that we could live and work in space, we had to have a better way to get there. So this was our first reusable spacecraft. It launched like a rocket, it maneuvered in Earth's orbit like a spacecraft, and it landed like an airplane. It was the first spacecraft in history that could carry large satellites to and from orbit. And since its initiation in 1981, it carried more than 3 million pounds of cargo into space, much of which built the International Space Station. Next slide. The Shuttle Mir program. This began an era of cooperation and exploration that had rarely been seen in human history. From early 1994 into 1998, 7 American astronauts spent nearly 1,000 days living in orbit with their Russian cosmonaut friends. The shuttle rendezvoused with the Mir 10 times. And again, this was the preparation for our International Space Station. Next slide. The space station is a research laboratory. In low Earth orbit, it flies 250 miles above the surface and travels at a speed of 17,500 miles per hour, orbiting Earth 16 times per day. Now, to me, that's really dizzy making, but doesn't bother the astronauts at all. The intended span of the ISS has been extended many times. Since many of the elements were beyond their intended lifespan, they've been replaced. It's modular, so it's relatively easy for our astronauts to do that. The ISS will continue operation right now as a working laboratory and an outpost until probably 2030. The first crew went up in November of 2000, and our next crew up, next slide, please. Crew 73 launched in April of this year, April 19th, aboard SpaceX. They will stay there until November, when hopefully another crew, Expedition 74, will take their place. And they will continue to conduct the advanced space research that's been done on the space station since its inception. Next slide. So what's next? Well, the Artemis program has already begun. This is our return to the moon after 60 years or more. NASA is exploring the moon for scientific discovery, technological advancement, and learn how to live and work on another world. Artemis 1 launched on November 16th of 2022, and it was an uncrewed flight just to simply test the Space Launch System and the Orion spacecraft. Artemis 2, next slide, please, is scheduled to launch in April of next year, and the crew has already been selected for that. And Artemis 3 is planned for launch in mid-2027 and will land at the South Pole. Next slide, please. Here's Artemis 3. So here we are looking at advanced spacesuits and construction materials to possibly colonize the moon as well before we start to colonize Mars. Next slide, please. This very busy slide just shows that there are over 1,000 uncrewed missions that NASA has sent into space since 1958. These missions circle the Earth, the Sun, the Moon, Mars, and many other destinations within our solar system, including spacecraft like the James Webb Space Telescope that is looking even further back into our universe. So this depicts the scope of NASA's activities. And with that, I'm going to turn it over to Richard.
Thank you, Ruth. Excellent job. I know Ruth is smarter than me, primarily because she always sticks me with the harder part of the presentation. I've got to help make sense of what's going on with space exploration now, which is not going to be easy. But let's consider for a moment NASA's current launch fleet. Here are the launch vehicles that NASA currently uses to launch unmanned and manned missions into space. The history that Ruth just reviewed with you, could lead you to believe that there's no, commercial entities involved, but that's actually not true. Ever since the late 50s, commercial companies have been building rockets and spacecraft, for NASA and for the Army and other entities as well. And each of these launch vehicles are manufactured by different companies, as you know. This is the current fleet to launch astronauts to the International Space Station. We rely on SpaceX currently, and their Dragon spacecraft, their manned Dragon capsule, flown aboard the Falcon 9. And that's how our astronauts get up and back from the International Space Station, occasionally catching a ride on a Soyuz spacecraft, a Russian spacecraft as well. Before SpaceX was certified to fly our astronauts, we were paying the Russians about $85 million a seat. That's a one-way ticket. So if you think air travel is expensive, consider that. But there is a lot going on beyond what you see on this slide here. There's actually 39 rockets currently under development by various companies and organizations around the world. And not just rockets, but also capsules and landing craft. And I've listed just a few of them here. These are some of the companies that actually have contracts with NASA or the European Space Agency as well. Now, I'm sure all of you recognize this young man. Elon Musk is probably the best known commercial space entity in the world. He didn't get to that position without a lot of help from the U.S. government. About $14.5 billion was awarded to SpaceX to develop the Falcon 9, the Dragon capsule, and the various other components that are required, as well as new launch vehicles and capsules, which are going to be used by NASA in the future. Well, that has paid off handsomely for SpaceX. The last time I looked, they were valued at well over $250 billion. Another very familiar face is this gentleman, Jeff Bezos, also owner of the Washington Post and Amazon. And last time I looked, he's received about $3.4 billion from NASA, primarily to develop a lunar lander, but also potentially carry astronauts and cargo up to the International Space Station. So commercial entities are very, very much involved with current space activities here in the United States, of course, and it started quite a long time ago. In fact, I have a few slides here kind of going back in history, back to 1983. President Reagan signed a presidential order pushing for an increased commercial involvement in the space business. The Commercial Space Launch Act was passed by Congress in 1984, legally authorizing commercial companies to launch their own vehicles with some government oversight. And to this day, certification is needed not just from NASA, but also from Federal Communications Commission and Federal transportation authorities as well. Jumping ahead a little bit, in 2006, the current administrator of NASA, the administrator at that time, Mike Griffin, rolled out what was referred to as the COTS program. I'll describe that in a little more detail. And then in 2010, President Obama accelerated efforts for commercial delivery of crew to the International Space Station. At that time, the Russians were our only way to get astronauts up to the ISS. Talking about the ISS, there were a number of programs at NASA to help the commercial entities develop resources that NASA could use. The COTS program is listed here, the Commercial Orbital Transportation Services. This is really where SpaceX got its start, developing the Falcon launch vehicles and the first versions of the Dragon capsules to deliver material to the International Space Station. But not just SpaceX, Orbital Sciences as well developed a capsule and launch capabilities. And to this day, they launch cargo to the International Space Station on behalf of NASA. There was the Commercial Resupply Services, which provided more money to additional companies such as Sierra Nevada, who I will mention again a little bit, Northrop Grumman, who's been in aerospace and aeronautics for a very long time. And then came the Commercial Crew Development Program in 2010, first 50 million, then the following year, 270 million, and later $4.2 billion were given out in programs to Boeing, SpaceX, Blue Origin, Sierra Nevada, Paragon, and ULA, United Launch Alliance, which is an alliance of several different aerospace companies. $8.6 billion has been spent or was spent on the Commercial Crew Development Program. That's a fair chunk of change. So getting back to the Artemis mission that Ruth had mentioned, there's been quite a bit of money spent here as well in the development of commercial entities and capabilities and resources. The Commercial Lunar Payloads Services, or CLPS, has awarded $2.6 billion in contracts through 2028 to develop the technology needed to deliver scientific instrumentation and technology to the surface of the moon. And the companies that are involved here include Astrobiotix, Firefly, Intuitive Machines, and Blue Origin. All are developing spacecraft for delivering technology to the moon. And there's the Human Landing System Program, or HLS. $6.3 billion has been given out to develop the resources needed to deliver astronauts all the way to the lunar surface. And SpaceX and Blue Origin are developing spacecraft specifically for this purpose. The Human Landing System is quite a complex program. The technology needed is quite complex. It is very difficult to land on Mars, for example, because it has a thin atmosphere, much thinner than the Earth, as we know. Here on Earth, we can rely on that atmosphere to slow down. When we're in orbit around the Earth, we're traveling at 17,500 miles per hour. In order to deploy those parachutes, those large parachutes that carry the capsule to the ocean or to a piece of land, it has to slow down to less than 200 miles per hour before those parachutes can open. On a earthbound reentry, we use the atmosphere in what's called aerobraking to accomplish that reduction in velocity. We essentially trade velocity for heat. And the temperature outside of the capsule rises to well over 3,000 degrees Fahrenheit, ionizing the air around it, melting any metal that may be exposed to that temperature. And various types of heat shields have been developed to either carry away that heat or to protect the metal from that heat. Well, SpaceX is currently working on that same problem with their Starship rocket that we'll be talking about a little bit. When landing on the moon, there's no atmosphere. So you don't have that to help you slow down, and you can't open up a parachute. So it has to be a powered landing, just like the lunar landers employed during the Apollo days. Here's a couple of artists' impressions or renditions of what our landers may look like. On the left is the SpaceX version of their Starship, the Starship HLS, which they have not built yet. On the right is the Blue Origin moon lander. You can see that they're very large vehicles, but actually the SpaceX vehicle is immensely large. If you take a look at the Blue Origin lander on the right, by the right-handmost leg, landing leg, you can see an astronaut bending over to give you an idea of how big that spacecraft is. Pretty big. Now look at the SpaceX lander on the left, and way down in the middle, between the left leg and the middle leg there, are two astronauts standing straight up. You can get a sense of how much larger that particular lander is planned to be. Other companies are developing landers as well. Firefly has built and successfully landed on the moon, their Blue Ghost lander. Unfortunately, it landed successfully, but it also tipped about 30 degrees on its side. If you're wondering, it landed near Mare Crisium, but that landing was considered to be quite successful, and they're going to try that again. Another company based out of Japan, based in Tokyo, iSpace, has developed the Resilience lander, and just this past Thursday, they made an attempt, or last week I should say, they made an attempt to land. Unfortunately, their lander failed and crashed onto the surface. Both the iSpace lander and the Firefly lander are designed to carry instrumentation and perform experiments on the surface. They will not be carrying any humans. So that's what's going on with the Artemis program. We'll revisit that in a few slides as well, but let's talk about the space industry in general. It's quite large, surprisingly large. In 2024, there was over 35,000 companies globally involved in the space industry. 3.5 million workers are employed. Almost 200,000 workers were added in 2024 over the previous year. Globally, there was 259 launches, most of them quite successful. The US itself saw an increase in the number of launches, primarily because of SpaceX. They're launching a lot of Falcon 9s. It seems like almost on a weekly basis now. Altogether, about 2,800 objects were launched into space. Now that includes not just satellites, but also the lunar landers that we were just talking about, and scientific instruments, telescopes, spacecraft traveling to Juno and Europa, for example. That's all in that tally. Of those objects, over 2,200 of them were US launched spacecraft. And by 2035, the market is forecasted to be $1.8 trillion. In 2024, it was just shy of $1 trillion. So it is growing quite rapidly. Why is that? Well, because of new technology that we'll talk about in just a few moments, the cost to launch something, particularly into low Earth orbit, has dropped amazingly low. This chart here pegs what the cost per kilogram has been for various missions, delivering scientific instrumentation, telescopes, satellites, etc., into low Earth orbit. Back in the Saturn V days, it was relatively expensive, but those were early days. Things didn't cost as much either. The space shuttle cost per kilogram was well over $50,000. Until recently, the cost of delivering something into low Earth orbit was hovering around $10,000 per kilogram. Well, with the introduction of the Falcon 9 and the Falcon Heavy from SpaceX, that has dropped amazingly low, approaching $2,000 per kilogram to get something into low Earth orbit. That's made it possible for a lot of companies to launch their own satellites, a lot of nations to launch their own satellites. Well, what has made this possible? We've all heard in the news about reusable rockets. SpaceX's Falcon 9 be able to land on the launch pad or land on a pad out at sea. Blue Origin as well is able to land back at the launch site. And there's other companies working on that technology as well. And that's part of the story. But a very significant part also has been the development of new engines for rockets. The leftmost column in the picture above it describes the engine that was used aboard the space shuttle, the RS-25 that was developed by Rocketdyne. And by the way, a newer version of is going to be used in the SLS rocket that NASA is building for the Ares program. Well, this rocket was the world's first reusable rocket engine. That was quite an achievement. After every mission, it would be removed from the shuttle, rebuilt, and inserted into another shuttle ready for the next launch. It was quite capable. It produced over 418,000 pounds of thrust at sea level. It was fueled by liquid oxygen and liquid hydrogen. So it's a relatively environmental friendly engine, if you would. Produces nothing but very hot water. How hot? About 6,000 degrees Fahrenheit. And as I mentioned, it's going to be used on the SLS. Both Blue Origin and SpaceX have developed newer engines, which are smaller and even more powerful. The Blue Origin BE-4 produces 550,000 pounds of thrust at sea level. Its fuel is liquid methane and liquid oxygen, or methalox, as it's often called. And it'll be used aboard that new Shepard rocket that they recently launched. And a rocket being developed by the ULA, the United Launch Alliance, the Vulcan Centaur. SpaceX, of course, has developed its own rocket engines as well. Its most powerful engine is the Raptor 3, producing 593,000 pounds of thrust, also powered with methalox. And this is the engine that is used for their spaceship, their Starship, which they're testing now. The Falcon 9, as an aside, uses an earlier engine, the Merlin engine. It uses 9 of those engines to launch a Falcon 9. Well, when someone tells you it's really not rocket science, this is what they're talking about. Yes, it really is rocket science. This is a simplified schematic of a RS-25 engine, the one that's used for the SLS and was used for the space shuttle. Simplified diagram. This is the diagram I use when I'm volunteering at the California Science Center under Endeavor to explain how that engine works. It's a very advanced engine. In fact, Rocketdyne had to go through about 1,000 tests before they could get it to run for longer than 1 second. The timing of everything is very complex. It has 2 pre-burners that power high pressure turbo pumps, which deliver the liquid oxygen and liquid hydrogen to the combustion chamber. It's all about physics. In a sense, it's really nothing more than applying Newton's third law of motion. You want to cram as much matter into a combustion chamber as you can, make it combust as quickly as you can to produce as much thrust as you can. And that thrust pushes the rocket into orbit, of course. Well, Blue Origin and SpaceX have borrowed from this design in various ways to design their own engines and further this technology, and they've done a marvelous job doing that. And that new technology is what's driving the new rockets, the new launch vehicles that are coming online, have come online now. The newest being the Blue Origin New Glenn, which launched for the first time. It was last year. Older than that is the SpaceX Falcon Heavy, which is a multi-core version of the Falcon 9. Also launching recently was the Vulcan Centaur. That was the one that launched last year. That was built by ULA. And then NASA has launched this SLS launch vehicle once already as well. But it's all about the numbers. How many kilograms or how many pounds of mass can you get into orbit? How much of that can you get to the moon? And if you look at these numbers, they've grown quite large. The SLS being the largest of the four here, with its Block 2 version, which has not been built yet, it will be able to deliver about 46,000 pounds of scientific instrumentation, astronauts, food, water, supplies to lunar orbit, or what we call TLI. It's powered with 4 RS-25 engines and 2 solid rocket boosters. But as amazing as these numbers look, they pale in comparison to what's coming down the pike. And what I'm referring to is SpaceX's Starship, also being developed with some money from NASA, as well as a lot of money from Elon Musk's bank account. Its capacity to low Earth orbit is a whopping 330,000 pounds, and to the moon, an incredible 200,000 pounds. It's powered with 33 of their Raptor engines in the first stage, and 6 Raptor engines in the second stage. Total thrust of this behemoth is 16 million pounds. This has flown 9 times. No single flight has been entirely successful yet. They have not gotten to orbit yet. They've got a lot of development to do yet, but they'll get there. And this will become a workhorse for both NASA and SpaceX in terms of their plans for not only the moon, but for Mars itself. We'll revisit that topic of Mars in just a few slides. So what does the space economy look like? Well, let's start at the bottom here, because this is really where it started. Communications, delivering satellites into low Earth orbit, medium Earth orbit, and far Earth orbit, as well as geosynchronous orbit. Satellites for communications, television, internet, telephone communications, etc. But also for agriculture and for monitoring the Earth's climate. There's thousands of satellites, not including the thousands that SpaceX has been launching, currently in orbit around the Earth, doing these kinds of functions. In the future, not too distant future, space-based tourism will take off. And we'll talk about that in the next slide. And in the long term, mining and manufacturing, as well. Talking about tourism, there's a company called Sierra Space that's developing a mini-me shuttle, if you would. This shuttle, called Dream Chaser, could actually fit inside the cargo bay of the space shuttle, NASA's space shuttle. But it is designed to carry astronauts and supplies up to the International Space Station, but also up to a space hotel that Sierra Space and Blue Origin are building. They haven't launched any components yet, but the orbital reef, as they call it, the first modules will be launched in 2027, just a couple of years away. for the primary purpose of tourism. So if you have $250,000 in your bank account, you can go and spend a week vacation up into space. NASA actually provided funding for a lot of the technology that went into this, about $130 million of funding, because this is technology that can be used also for a space station that NASA is planning to put in orbit around the moon, called the Gateway. I mentioned mining. In the distant future, there's a possibility of mining asteroids. There's a lot of metals in asteroids, as we know, but also on the moon itself. And NASA is actually actively planning to support robotic mining on the moon during the Ares program, primarily to mine frozen water in the regolith that they believe is at the South Pole and in the deep crevices or deep pockets of craters where the sun does not melt any of the water. There is water on the moon, and it's primarily frozen. And if they can mine that, they'll be able to generate fuel for rocket engines, generate electricity, and also hydrate astronauts, there. But there's the potential for other mining as well, mining of aluminum, iron, magnesium, helium-3 for fusion reactors, and the possibility of rare earth elements also. If the current prevalent theory about the formation of the moon is right, then what's buried on the moon is pretty much what's buried on Earth, deep in the mantle. So there could be a lot of potential for mining opportunities one day on the moon. And the same could be said about asteroids. This is a poster of the estimated value of different asteroids that have been identified and quantified. One of the largest asteroids, Davida, has a lot of nickel, iron, hydrogen, and other elements as well. And based upon its mass, somebody calculated that it's worth in the order of 26.9 or roughly 27 quintillion dollars in today's dollars. What's a quintillion? Well, think of 18 zeros. 1 times 10 to the 18th power, or another way of saying it is a million, millions. When you think about the national debt, they usually talk about trillions, which is a million millions. Well, here's a million times that. So various asteroids could, in fact, be a real bonanza far in the future for commercial entities that can send robotic and maybe manned missions, out there. Getting back to Earth, let's think about Mars. We talked about NASA's lunar missions, the Ares program. Early in the development of the Ares planning, they considered making that a stepping stone for going to Mars. And that's still the current thinking at NASA, although things may change, as we all know, based upon funding and new priorities. But back even just in 2024, a working group at NASA put together the Mars Exploration Program, or MEP, in a document that's readily available on NASA's website. MEP lays out the rationale for going to Mars and what is planned to be done there. In short, it's a science-driven program, primarily focused around understanding the potential for life. Did it exist? Can it exist? Can it exist in the future there? It's a human robotic combined type of effort. So there'll still be robotic rovers on Mars, working in conjunction with manned missions. And it's based on the M2M technology, that's the Moon to Mars technology development program that they had previously proposed, which was figure out how to get to the moon again, work in that space, develop technologies that will help us get to Mars, and do that by developing commercial partnerships and leveraging systems that are developed along the way. This all may change. In fact, that's being discussed as we speak. And what will come of this, I don't know. I should have said at the very beginning of this presentation, any opinions expressed here are those of my own and of Ruth's and don't reflect NASA's. So when we get to Q&A, I bet you there could be a lot of questions about this. I'll do my best, but those opinions are going to be my own. We're not the only ones thinking about going to Mars, though. NASA is not the only group of people giving that thought. Elon Musk is giving it a lot of thought as well, as you know. And there's a lot of question about, can he get there with his Starship, which is, ostensibly designed to go not just to the moon, but also to Mars. Well, recently there was a paper just in May published in the journal Nature, where a gentleman by the name of Jack Kingdon took a look at this question. Can you actually get to Mars safely with astronauts? And he determined that if you shoot for a 90-day transit using the Starships versus a 9-month transit, you can get astronauts to Mars safely. Now, the main problem getting astronauts to Mars is the radiation levels, the total exposure of radiation that they would experience. A 9-month trip to Mars would put the astronauts in the red zone of the lifetime limit that NASA places on radiation exposure for astronauts. But if you can shorten that to a 90-day trip, you can do that. So this gentleman figured out that with 2 crewed Starships, each requiring 15 refueling missions in low Earth orbit, and 4 cargo ships, each requiring 4 refueling missions in low Earth orbit, resulting in a total of about 45 launches. That's on a rate of about 1,000 launches a year. SpaceX could actually do it. So it's an interesting exercise. The technology may be there to do this. Time will tell. And Elon certainly is motivated to get there. And NASA as well is motivated to one day get to Mars for scientific reasons itself. So hopefully what we described here today helps clarify the current status of the space industry and the commercialization of space as well. I want to thank you for your time, and we'll open up the floor to questions that you may have.
First, let's thank Richard and Ruth for the presentation. I'm ready to go. How about you guys? Okay. Go ahead, Doug.
All right.
Use the microphone so they can hear you.
First question. Can you go back that last slide with Elon Musk going to Mars? All right. So 45 launches of the Starship Super Heavy, which hasn't hit orbit yet, successfully. That's to Mars, correct?
Well, 45 launches to refuel, deliver the technology. And,
two Starships, the 15 refueling missions, 4 cargo ships, and all that stuff. That's to Mars.
That's correct. To get 2 crews.
Also, or is that one-way trip?
since this was not a SpaceX study that was done,
I know.
and he is talking about colonization,
I know.
I think that's an open question.
Sounds like a one-way trip.
So I'm just saying, in my opinion, we're not getting to Mars safely in about 100 years. I'm just.
Well, you definitely couldn't have too many trips back and forth because you'd have too much radiation buildup.
Yeah. And once you get there, what's protecting you there? And then, so, all right.
I'm not arguing with you.
Oh, come on. Tell me that they can actually do this.
Well, let me, in the form of a question, counter you a little bit, Doug, because Sputnik was 68 years ago. That's basically my lifetime. So the rate of advancement in space exploration doesn't seem to be slowing down, but
No.
rather increasing.
Yeah.
So maybe this is a very speculative estimate, but Richard and Ruth, give us your opinion on this rate of space exploration. Is it going to continue at this rate? Is it going to increase or slow down? What's your reading of the tea leaves here?
Ruth, do you want to chime in?
As you say, the technology is increasing exponentially and has just in my lifetime and yours. But it all depends on funding and priorities in space. So it's kind of hard to read those tea leaves because I'm not sure what they are yet.
That's
Okay.
well put, Ruth.
On the topic of funding, isn't the commercialization less dependent on public funding and more private funding and profits now? So is that also a trend that we're seeing?
Excellent question. So SpaceX and Blue Origin and these other companies, in all likelihood, wouldn't be doing and wouldn't be able to do what they're doing now without government funding. SpaceX couldn't have developed their initial technology even and attract the investors that they did. So you have that end of things. If government funding goes away, that leaves a big hole for commercial companies. The other potential big hole for commercial companies, of course, is the bigger one, and that's profit. Sending people to Mars sounds great. It sounds futuristic. It is exciting. We would all be glued to our television sets. But where's the profit? And at some point, investors want to see a payback. So it's a lot easier for a profit to be made by sending space tourists into low Earth orbit at this point in time than would be to send astronauts to the moon to build a colony there and to spend the rest of their lives there. Where's the profit?
Yeah.
Your thoughts? Any other questions, comments? Well, some of the richest men in the world are investing in this, so maybe they know something that leads to their investment, right?
They're getting a lot of government funding to keep everything going.
Well, yeah, it was subsidized from the very beginning, right?
As test.
Mhm.
That's not that's
Yeah.
a positive thing, actually. We get good science out of it.
We do.
Going to Artemis 3. We've had nothing but problems with trying to get the SLS going and so forth, the heat shield and so forth. Are we any closer to more than a 2030, 2035 to get Artemis 3? You think?
Ruth, do you have a comment on that?
Yeah, I don't know. There are a lot of little glitches that have to be worked out in that. And I think again, it's going to depend on the funding and the priorities if that continues to be a top priority program.
I'll add there that President Trump seems to be quite enthusiastic about not necessarily the Artemis mission, but sending people to Mars.
Yeah.
So there is a budget that's going through Congress right now that appears to cut NASA's science budget back significantly.
Right.
What it does, what it's going to do to the manned mission, we don't have visibility to that at this point in time. We haven't been briefed on that yet.
No.
So, but Ruth is right. It's all about funding. It always has been. That's been the story since the Apollo days. Apollo was actually envisioned to send astronauts to Mars eventually.
Seriously?
Yeah.
Wow.
Werner von Braun, thought that was the next logical step for the Saturn V. That program came to a premature end, primarily because of funding and lack of support.
Yeah.
In one of your earlier slides, you showed all the different space capsules, and you mentioned Boeing and Starliner very briefly. But let's go back there, and because we all know that the recent history of that vehicle, and I wanted to ask you if you see that Boeing continuing their efforts, because are they out of funding? Are they
about spinning it off?
Yeah.
Selling it.
Anyway, I just wanted to get your input or your comments on the Boeing program, if it's has a future or not.
The last I saw from NASA was that they were still standing behind the Starliner. I think it's all up in the air because of the funding, question at this point in time. Boeing certainly has had quite a number of quality control problems that they're trying to deal with. So, have you heard any more than that, Ruth?
No, we haven't.
Yeah. So NASA has not abandoned the Starliner at this point in time.
Actually, my question was, have you heard anything from Boeing? Because they're the ones that are going to decide whether they want to go forward or not.
I have not, no.
Interesting. Well, any other questions? I thought the presentation was excellent. The way you started with the background of the space program gives us a foundation of where we've come from, and then a lot of the present day accomplishments, and then just a taste of what we're looking forward to get back to the moon and to Mars. Very, very great presentation. Thank you so much. Let's give them a round of applause.
Thank you so much for having us.
We appreciate it. We appreciate your questions as well.
Thank you. Doug, go ahead and make your.
I have one more kind of a question. After reading about 3 books on Eisenhower and the early space missions and so forth, one of them was saying that Werner von Braun told Eisenhower that he could get us to get a ship in or get something into orbit before Sputnik. But Eisenhower said it was a military rocket, and he did not want to do that with the Soviet Union. It's the way it was. So that Eisenhower, there was some things saying that Eisenhower actually wanted the Russians to do it first, so that something orbited us and we weren't worried about it, so that we could orbit cameras over Russia and they wouldn't be able to say anything about it. So we've actually pulled back. Now, have you heard that? Is it bunk? Is it possibly true?
You've never heard it before.
Neither have I.
They had, well, we know that the original space race was a competition between countries, right?
Yeah,
Right.
And you kind of wonder now if that's what it's going to take to spur either further development is a competition between companies, countries, nations. So that could be what triggers us to go further.
companies are only gonna be for profit.
True.
Countries is for pride,
True.
and the
Yeah.
Chinese are gaining on us.
Yeah, and we didn't address that at all in the presentation, but China seems quite motivated and capable of setting up lunar bases before we do.
Yep.
So that may be what spurs, the United States into action.
It's true.
Oh, I did have a question or a comment about, you mentioned that Soyuz was $85 million a seat to get to the space station. I know that those, space tourism, that those folks, those Hollywood stars and whatnot are not paying that kind of fee. What is the rate now to get into, let's call it low Earth orbit, not just get into space, but into orbit?
Well, interestingly, Jeff Bezos has been silent on that question.
Yeah.
I think if you have to ask, you can't afford it. Kind of like shopping at Nordstrom's, but it's not cheap. Now, I know through I actually had met another solar system ambassador some time ago who put down a deposit to fly on a Virgin Galactic. And that seat was going for, at that time, 150,000, I think. That was suborbital.
So the price is coming down. Well,
Well, like I said, cost per kilogram.
Again, thank you both so much.
Charge you by weight, though.
Oh, yeah. I'm going to be less than you. But if the cost per kilogram of payload, you mentioned like the shuttle cost over $50,000, and now the Falcon Heavies are, what did you say, like $2,000 a kilogram?
Approaching 2,000, yes.
Yeah. So it's getting reasonable. I mean, maybe we'll put up our own satellite, or you guys.
Are you gonna lose enough weight to?
No, I'm not talking about human satellite. I'm not volunteering. Get one of our younger members. Like,
We could put our own telescope up there.
yeah.
Well,
Space
there's high school students building CubeSats that are getting launched, so it's cheap enough that individuals potentially could afford to put, not themselves, but a small package up there.
Okay, I'll put that on the agenda for the next board meeting. Okay, see if we can raise the dues a little bit. Okay, again, Ruth and Richard, thank you so much. Excellent presentation. We thank you so much.
Thank you.
Our pleasure. Have a great one, guys.
Have a good evening.
Thank you. Okay, let's shift over to our announcements and the rest of our program here this evening.
Let me bring this up here. Let me show.
Or Eric's doing that theoretical question. Assume you have all the disposable income you need. What would you pay to go into space?
Nothing.
Nothing. You don't even want to go,
Hell no.
regardless of the price. Anybody else
I
going?
could.
You have all the money that you need. What would you pay? 50 grand, 100 grand, 150, they
If I
say?
have all the money in the world,
No, you have enough disposable income to spend it on this
My name is no.
adventure. And maybe he's not gonna ask you.
Where is this to go? Just in orbit or?
Well, that's a good question, because getting into orbit is different than just going into space.
right?
Right?
Right.
Just
Oh,
getting above the
Yeah.
Kármán line is what, 60,000?
I don't think that would appeal to me, but hanging out in the cupola of the International Space Station watching Earth go
That would
by,
be cool.
that might be pretty cool.
I like
Yeah.
the sound of that.
You know, with me and my camera and, you know, yeah.
I
Tell
do
us
that.
Um. We had Tom Stafford come over here, he was in Polo night.
Yeah, General.
And yeah, when he retired, then rather, excuse me, my cousin Joe retired, he was the head of, I can't even remember the name of it. All of the, I think all the engineers for the Air Force. And they had a retirement party for him over there in San Antonio. We invited General Stafford to come over there, really good. And, General Stafford was sitting right in the dead square, and he started talking about General Stafford. There must have been at least 200 Air Force generals there, probably more. And my cousin Joe said, you know, you're a brave man, General Stafford, but I wouldn't go up there. Hell no, but I never go up there. Are you crazy? And all the generals started laughing. And I think they kind of understood the seriousness of going up in the space.
Yeah.
It is a really dangerous.
Pretty risky, yeah.
Yeah.
Yeah. Humans are pretty fragile.
We've only lost as many people as we have.
But I'd be the one where you get lost, I guarantee.
They're at the end of the space shuttle, or near the end of the Apollo program, there was a scientist astronaut program trying to develop actual scientists to go up in space rather than pilots, exactly. And they had to be, because they were going to be astronauts, they had to be jet certified. And that killed half of them.
Yeah, sure.
Just the G forces?
No, just learning to fly a jet.
Oh,
And then you have to maintain that, flight stats, so you can't just learn them and forget it, you have to maintain full time, and then,
Completely different skill set than science.
Yeah, the guy that wrote the book, he said he dropped out of the program, when they lost funding, when the Apollo lost funding, he thought, how long is it going to be? Am I gonna have to fly a jet, every week for all these
oh, I
years?
see.
And, anyway, so he dropped out because of that.
Yeah. Good
And
point.
he said only one or two people actually stayed in the program and make it to the shuttle.
Mhm. Interesting. Okay, then let's go ahead and proceed. Eric, we have our announcement slide.
It's shared it. Fair.
There you go. All of our regular stuff, you guys can see it on the website calendar. Highway 4 is coming up on the 21st. We're back out at Oak Grove Park on the 28th. I think we were anticipating a shortage of folks because you're not going to be there.
So, June 28th, I'm not gonna be here. I'm gonna be down,
You're not in.
South. Tim's not gonna be here, so we're gonna need people at the park, and I gotta hand the keys off to somebody else, so. We're gonna need some help out there. I'm gonna put a call out for volunteers and see if I can, but I'd really like to have people to actually chime in.
June 28th.
I can be
It's also the
there.
same day as a high altitude.
I know.
It is the same day as high altitude.
All right,
Maybe.
So that was, it wasn't by design, but it was acknowledged that that was going to be a conflict for
Yeah.
the club. So
July 5th.
Yeah. I did talk to Omar. He is planning to be at Oak Grove on the 28th.
Okay,
So
Eric, you think you can make? the
Yeah, I'll be
time? Okay,
Yeah, we're.
you'll be there?
So
I'm not here.
Yeah, you're not. Jerry?
I can see you right there. You're not here though. Okay. All right. And then July 10th, our own Pat Lehman has an excellent presentation. I called it a 3D atlas of the universe.
I don't know what you're talking.
Yeah. We'll have to get somebody else in. You guys don't want to miss this. This is going to be, I'm not going to spoil it for him, but it's a really cool presentation Pat's got in store for us. And then Highway 4.
Just a globe, right?
Yeah.
It's a finest.
Yeah. Oh, one of those. Okay. And then Pat shared with us a picture of M13?
Yes, I took that in my backyard in Tracy, with the Dwarf 3 camera.
Wow.
And, so that was, I look at my notes, that was 90-second, 60-second exposures stacked.
So 90 minutes?
Yeah, 90 minutes. I'm impressed with what that camera will do.
Yeah.
I did run the denoising on that, to knock down some of the spurious signal, but,
Yeah, that's good.
Okay, and then Pat showed another photo on the next slide. And I'll let you tell us about this,
yeah,
Pat.
so again, that's for my backyard. So that's, Bode's Galaxy and the cigar, so and 81 and 82. And it was the same, it was 90-second, 60-second exposures. Equatorial mounted, with the Dwarf 3 camera. I'm enjoying it. I just don't want to break this second one, but the Dwarf 2 motor died on me.
It's very much worse.
What's that?
Captain is very all right.
Yeah. And my yard is not that dark. You know, the sky is not that great, but just the long exposure
Wow.
really does work.
It's great. Yeah, the stars are pinpoint and a lot of good resolution in those galaxies. So, excellent. Thank you for sharing those photos with us, Pat. Okay, I want to thank everybody that's been out to public outreach events lately. It's been a lot of fun out at Oak Grove. As you can see here, the top picture, Jerry brought his scope out and then he left. I don't know where he went. It was open to the public though. Yeah. And then Omar shared this photo of his presentation at Live Oak Elementary in May. Had a really good turnout and a really enthusiastic science teacher there that invited him out. So I want to thank Omar for doing that. Yeah, thank all the volunteers that come out for these events. Okay, Eric, the next one, please. The New Moon Challenge. This was the photos from May 27th. These are the ones I know about. So Ray, you're on Zoom. Got your photo in there. Ray always does an excellent job of documenting all his settings, the location, the time. Really good photo there. Ray, aren't you using your origin? You're on mute. I'm pretty sure that's what Ray's using up in Elk Grove. Jeff sent me this text. He says, I saw the moon, but my cell phone can't get it. So I guess that counts as he saw it. We'll trust him, right? And he documented it in a text. So I captured the text. And then this is my kind of poor photo off my rooftop that evening. And I don't know how many of you have tried this. I know Casey and you all have, but the sliver moon is not an easy thing because you sit there and wait, and the sun's going down, and then the moon's also going down, and you're going to lose the moon anytime now. And it's not visible until that very sliver finally appears, and you got just a few minutes to catch it in a photograph before it sinks down below whatever horizon you're looking over. And it's kind of pretty. Just that little sliver. And then Casey, you took some great photos. Why don't you tell us about where did you take these and how did you get the focus so good on that sliver? Oh,
It's always wide open out there, so I could see the west. We can't see the west from our house.
No birds.
There were some birds.
We got a barn owl.
We got a barn owl, yes.
okay.
Flew right toward me. And it was, so there was like a huge horizon because it's just so flat out there. So we had a long time when we could watch it. It was really, really windy. I used the car to block the wind. It's always windy out there to block the wind.
So Woodbridge Road, north on I-5 to,
It's west of I-5.
and then go west.
Yeah, so you get off on Turner Road.
Yeah.
And then you go north along the frontage.
Oh,
and then
okay.
turns left under the bridge.
Oh, yeah, because then it's just ag fields all the
Yeah.
way to the west.
Yes, and then there are a couple of locations there that the state owns where you can pull off and look at birds. And this is oh, we didn't even use those, that's right, we were gonna pull up on the north property and then the south property, but there's also a place called Pond, what's not what it's called, anyway, it's Pond 6. And people park right there, it's also owned by the state, people hunt there, and so you can park your vehicle right there, and that's where we park, and it was just wide open expanse, and it was really nice, and so we were able to see it. I found Jupiter first, actually, before I found the moon. And because that's what I was looking at my app, like, I know Jupiter's.
Oh, yeah, I think I
I'm not
caught,
sure if it's in that one. I
I saw Jupiter was up at the same time.
Yeah. And so
And then how are you focusing?
I had a try my 600 millimeter
And you're manually focusing?
manual.
Uh-huh.
Yeah. So I had a bunch of shots and many were not in focus.
Yeah.
Because I'm blind. And so it's really hard when I have to manually focus, but it
Did it work on just on straight on infinity?
no, I mean, you start on infinity and then you dial it back a little bit and then, I mean, I
That's what
just
found too.
I
Strangely.
did it with, so sometimes I pulled the lens back to like 200 millimeters, 400, but I focused on 600, I think, and then brought it back. So, but I could see if it was in focus or not, and I took several shots.
A long exposure or?
Oh, no. I shoot really high ISO, sorry, I still call it ASA. It was probably 8 to 10,000. In fact, as it got later, then it's like 125,000.
Uh-huh.
And then I just kind of work on that with, what did you call it? Cleaning it up, whatever it's called.
Post-processing.
Yeah, processing post, yeah, but there's a term that they use, right, but if you use it too much, then you lose the shine, the clear on the moon, so.
Oh, okay.
So you kind of leave that grain in there so you can get the sharpness. But I want to tell you that there was a person at the last start party, a young lady that didn't have really much interest, but her mom made her come. She just wanted to think of something to do with her kids. And so, showing her the moon through our telescope, and she goes, and it was quarter moon, right? And she said, wouldn't it be nice if you could just see it? It's really pretty when it's that sliver moon. I go, hold that. And I'm showing it to her. And as I'm doing that, Jacob comes over and he goes, I got the quarter moon. I got it. So the sliver. So he also had it and showed it to me. And he got it with his cell phone. And so I just wanted to say that he didn't send it in. He said he didn't know where to send it. And so I said, just send it to the email that sent it to us. Just send it to anybody and they'll get it. So I thought he was going to.
Oh, okay.
And so anyway, we're showing our pictures to that girl and she was really into it.
Yeah.
She was
Oh,
like,
cool.
really liked that. So that was fun that it just came up. I explained that there's a contest and we all do that. And so.
Yeah. Well, I've got 3 consecutive months. I think you've got 2, Casey?
I only not consecutive. I missed 2 months.
I think Ray's got it 3 too, and Jeff. So
And Jacob has at least, I think he has 3.
Yeah.
Because he said, I want to win.
yeah, we got to get 12 months. This is the challenge, right? So,
So my opinion for this month, I think Casey wins for composition.
oh, yeah.
Absolutely, yeah.
Nice shot.
Yeah. So mark it on your calendar. June 25th is coming up. So the new moon is at 3:30 a.m. So that night of June 25th,
17.
yeah, it's 17 hours old. You should be able to catch a nice one. And then the next one on July 24th.
I'm wearing checks. Sorry. So we don't have a win.
So put those dates on your calendar. I'll try and send some reminders out ahead of time too. So it's been fun. Okay, we've got another astronomy target. Oh yeah, the Target store in Lathrop. Did you guys get the newsletter? And in the newsletter, Eric's published
Oh,
the two target of the month. So Eric, let me ask you to talk about them. And I found some images on the web. I'm not sure but has anybody tried them?
I have seen the wild duck before visually, yeah.
Mm-hmm.
I have never seen the blue horse head.
Wild duck is really pretty.
Yeah.
And good binoculars and really dark skies, it's gorgeous.
So I chose these to be a pretty decent view during the new moon. But anytime during the month, you should be able to see them. So I just I chose sort of a easy visual object and then a harder imaging object. I think that blue horse head is going to be a difficult
Yeah, it's
difficult go.
Pat, put your dwarf on it and see what you get.
Yeah.
Ray, put your origin on it and see what you get.
But it is quite large. It's 4 times the full moon apparent size for that blue horse head. So it's pretty large.
Mhm. Yeah, but to get that kind of image in that color, it's going to take a lot of exposure. So, and then look in the newsletter for July. We'll have 2 more new images for target of the month. Okay, next slide, please. We've got a short video that Eric's going to play for us, and Dr. Tyson has an opinion that he's going to share with us. I wanted to see if you guys agree with it, what our discussion's like. So we'll ask Eric to play that.
Minimize this. Let me open this guy up.
We have no idea how much we don't know in any real terms. However, if we look out in the universe and we look at all of the forces that are driving what's going on, we actually can quantify how much of that we know. And it's about 4%. 4%. About 4%. So in other words, there's phenomenon going on in the universe that to this day stumps us. And you add up all the stumping phenomena in the cosmos, and this amounts to the dark matter. We don't know. 85% of all the gravity in the universe has a source about which we know nothing. We call it dark matter. With dark energy, the universe is accelerating in its expansion against the wishes of the collective gravity of all the galaxies. We don't know what's caused. We can measure it, but we don't know what's causing it. Added up, it's 96% of all there is. So we're really on the precipice, staring out into an abyss of ignorance.
An abyss of ignorance. Oh, speaking of an abyss of ignorance.
Good one.
You raised your hand. Is he right?
Yeah.
Well, I just saw an interesting article. It was talking about the cosmic microwave background radiation.
Yeah.
And James Webb Space Telescope has been finding a lot of early large galaxies that have formed much earlier than the model would predict.
Mhm.
And so this article is talking about how I think something somewhere on the order of like 4% to 100% of the cosmic microwave background radiation could be explained by just early galaxy formation. And so that idea is sort of putting the Big Bang theory on
Subject to.
subject to reanalysis.
Mhm.
But so I don't really know. So I guess my point is there's still a lot in our model of the universe that we don't know, which is I think the point that Neil deGrasse is trying to say. But yeah.
Well, he's saying 96% of the phenomena in the universe we can't explain.
That's nothing new. I mean, he didn't make that up. And it's been proposed for quite some time now. I don't know where it came from. Other than, one possibility is if you look at the acceleration of the universe, we say how much matter could actually be causing this kind of behavior. Maybe that's where the 96% comes from.
In part, we don't understand.
Yeah, except that a lot of scientists break the idea of dark matter down as being different than dark energy. And they say like dark matter might be worth about 36% of that, and dark energy is all the rest.
Mhm.
And the difference between the two of them is that dark matter is simply matter that doesn't interact with light. You know, we can't see it. And dark energy, we're just in the dark. We have no idea. But yeah, I don't know how they get down where the 96 wooden numbers come from.
Yeah.
How can we know what we don't know? I mean, Rumsfeld, the former Secretary of Defense. Yeah, that's like what happens. He's right. You know, one thing is right about it.
It's a known unknown is what Rumsfeld would call it. Unknown.
We don't know what we don't know.
Actually, on the same subject, the New York Times science thing today was talking about biology and proteins. And they always assumed that proteins needed to have hundreds of amino acids. They're just now finding there's tens, maybe tens of thousands of proteins with a dozen that we didn't even know anything about. And we sequenced the human genome, but we don't know.
Didn't find those proteins.
It's just like they didn't think these things even existed.
Mhm.
Now they're everywhere because now we know what to look for.
Yeah.
So, yeah, we are ignorant.
It's like when you buy a red ball, all of a sudden you see red balls everywhere.
Yeah, yeah, it's true.
But what this makes me think though is that, you know, the human species, the human race has been around, what, 300,000 years or so? Call it, plus or minus. But the universe that we're dating at 3.8 billion years old. So the amount of time that humans have been around is such a small fraction of the age of the universe. But look how much we've learned about it. We've learned 4% of it. If you use this measurement, we've learned 4% in that 300,000 years.
So you gotta go, you know, how ignorant we were just 100 years ago. And what we've done in the last 100 years, what we've done in the last 10 years, you know, yeah. I mean,
Like their point tonight, where Sputnik was 68 years ago. And look how far we're already talking.
everybody thinks ignorant is a horrible word. I mean, I'd raise my hand immediately, but no, we are completely, everybody is ignorant of a lot of stuff.
Yeah.
And most of us think we know more than we actually do know, is the problem.
Right.
You know, and that's what, for me, this is what astronomy does for me, is it keeps me humble. It's like, you don't know anything. It's just,
Like there's different sizes of infinity.
Yes.
Where that.
Yeah, good discussion. Yeah.
Next video?
Yeah, next video, we've got this one's, I think, interesting as well. It's somewhat related. It's the duration that different spacecraft Okay, so what was it, Voyager 2 to get to Pluto? New Horizons, 9.5 years to get to Neptune, like 12 years.
9.5 to Pluto.
Is it?
Then you got things like the Europa Clipper. So we launched it a year and a few months ago or whatever. And rather than send it to Europa, we sent it to Mars. It
Oh,
went
it's going to
around
do a
Mars.
gravity slingshot.
Actually, it slowed it down because what it did is it went around Mars the opposite direction to slow it down and sent it back to Earth. It's gonna catch up to us in a year from now, Christmas, a year and a half from now, Christmas, okay? And then slingshot itself to Europa.
Oh, I see.
So
Why did it go to Mars first then?
I don't have the math for it. Evidently, I
I
mean,
think that's
somebody,
what they wanted it to
somebody
do.
knows that was the quickest way to get there with the fuel on it and so forth.
But it's on its way to Jupiter.
Not yet. It's on its way back to meet us here on Earth.
And how long is it supposed to take to get to Jupiter?
I think it's another 4 years.
Maybe it needs the gravity assist to get there quicker. Was that the idea? The sunshine rays?
I mean, I trust the guys at JPL to figure out the math.
That's why taxes are so heavily regulated.
Taxes. Yeah.
But yeah, Mars, Earth to Mars, Mars to Earth, then to.
Yeah, it's amazing. These vehicles are going thousands of miles an hour, right?
Well, and then it comes 17 when they leave here, and then they try to get a boost to like almost 30 if they
Yeah.
get a good gravitational
And,
sense.
and it takes years and years within our own solar system.
I guess that's probably what it was all about, was trying to get a good gravitational assist, and the way to do it is to bounce back from Mars back to us, and then.
Yeah, probably conservation of fuel and
It's all conservation
Mhm.
fuel, yeah. Don't have to launch the fuel to get it.
yeah.
Actually, those numbers seem quite low to me, actually. I'm surprised we can get there that quick.
The duration.
Yeah.
Uh-huh.
So Pluto, and what was that, 9.5 years? That's
New Horizons was
Well,
9.
and it also did a couple of gravity assists, I believe.
pretty good.
Must really boost the speed of it.
Yeah,
So, I've heard that, I read that Voyager 2 is the faster of the two, right? That if it went to the nearest star, I mean, it's outside of our solar system now in the interstellar space, but if it went to the nearest star, which is Proxima Centauri,
sorry, right.
that nearest star is like 4 light years away.
Mhm.
It will take it 70,000 years to get there. You can't comprehend these kind of distances, right?
The human brain cannot
Now,
grasp.
My brain says, I bother.
My brain says, wow, you don't even need to drop acid.
Yeah. Now, there's so many zeros, you can't count them. So
Mhm.
70,000 years to get to the nearest star.
Actually, Voyager 2 launched before Voyager 1.
Mhm.
Voyager.
I don't know if like you guys, I get on Facebook or I watch my computer at night and those reels start coming up and you got to filter out the junk, right? But some of them pop up and they're really kind of thought provoking. Speaking of thought provoking, did anybody do the Astro Word?
That's what I want to do.
You left it at home? Did you finish it? Don't say the answer. Okay. I finished it. Anybody else? Okay, I think we're gonna roll it over to next month. Yeah, Jeff came up with this. I can tell he put a ton of work. I don't know how he does it, but see all these moon-related terms at the bottom? There must be 25 or 30 of them. They're hidden in that matrix of letters. And once you go through and find them, then it's going to spell out some secret message, some that has very deep meaning. Okay, so Casey and I are not going to tell you what that deep meaning is, but work on it, print it out. You gotta have a hard copy.
This is Doug's enigma.
He's staring into the abyss of ignorance.
Pretty sure there's a program that
Yeah, you can put in the stuff. and it
you put in the
shoots-
words
it
that
spits
you
it out.
want and it'll scramble up the letters for
In my
you.
first programming class, we had to do that,
Yeah.
do a word scramble and grade program.
Teachers use that all the time.
Yeah.
Oh, but
So he didn't
I'll
just.
tell Jeff he
okay,
doesn't deserve the
that's
credit,
here,
Christie.
here. Huh?
I'll tell him he doesn't deserve that much credit then, doesn't he?
No, wait, he does. I think it's pretty cool, because you still have to come up with a
All
list
the
of words you're gonna put on it.
He still did the work.
I forget, was this the one, or was it last month where it was from years ago? That he.
It was one last month.
Last month.
Yeah, that I stole from him and he printed it in like 2006. I think he found the same program this, that, like you said, Christie makes the.
The word searches.
Mhm. Yeah, they're kind of fun. Okay, well, that's all I've got. Anybody else have anything for the good of the order?
Could I run a quick test that will save Doug maybe $150,000 or $200,000?
Sure. Oh, is it-
Let me see if I could join the meeting real quick. This is a test that Eric and I were gonna do for next, oh, that's my wife. So
Okay.
that's Jackie. She would
Can I
be
stop,
happy
can I
to-
stop recording now?
Oh, yeah, please.
Okay.